So, in the last class, we have discussed about the active and passive devices, and I have told you that active devices have their own energy, while passive device does not have their own energy. Passive devices examples are resistor, capacitor, and inductor. By active devices, battery, generator, okay, alternating generator or DC generator, whatever may be, these are example of active devices. Today we will take some more terms, technical terms that are all in pair. One is linear, and the pair word corresponding to this now this is a very important term. Okay, we have to understand it in a generalized way. In general, whenever I ask to any person what is linear, then he will say, sir, if in the graph it is a straight line, then we call it a linear. Is this impression is your mind? Do you agree or not कि एक ग्राफ की अगर ग्राफ खींचे x और y के बीच में अगर वो स्ट्रेट आता है तो वो लीनियर है, ऐसा नहीं है. Is it clear? Here in our circuit theory or even in our control system, then in the next semester, in the next class, you will learn about control system. This word is very important. So I will focus that you should concentrate on this word, that is linear. The linear means any system which obeys the principle of superposition. So what is a linear system? What is a linear system? Which obeys the principle of superposition. Now definitely you ask, so what is the principle of superposition? Is it clear? What is this principle of superposition? Is it clear? Super means, in fact it is imposition. एक के ऊपर एक, ठीक है? But in this is just I have given you a little meaning. Superposition means to impose one over another, and I think so in lower classes you have gone through superposition theorem also. Is it clear? But what is inside there? It is the inside there is the two laws are there. Okay, one is called additivity and another is called homogeneity. Clear? One is called additivity and another is called homogeneity. Now if any system obeys two laws, both laws, not single law, you got my point? What I am saying? If any system, any device is obeying both laws, which two laws? Additivity principle and homogeneity, then we call such system as a linear. Means it is obeying the principle of superposition. Mind it, if the system is obeying only one law but not the other law, either additivity or homogeneity, system will not be called as a linear. अगर एक ही लॉ को obey कर रहा है और दूसरे को नहीं फॉलो कर रहा है तो वो सिस्टम लीनियर नहीं है. ठीक है? अब आप definitely you will ask, sir, what is additivity and what is? You will ask or not? Is it clear? So there is a mathematical derivation is there, mathematical explanation is there, okay, which you can apply on any system, and accordingly you can say yes, the system is obeying additivity and homogeneity or not. Is it clear? If it is obeying both, we say it is linear device or linear system. You got my point? So from now onwards, if somebody asks you what is a linear device, what you will say? Which obeys the principle of superposition, in the sense which obeys the principle of both additivity and homogeneity law. You got my point? Okay. You will not say, sir, if it is a straight line in the graph, it is linear. No, it is just a simple example. It is an example of that linear system, but this is not the correct definition of linear system. ये linear system की definition नहीं है. अरे समझ में आया कि नहीं आया? Is it clear? Okay. Okay. Now you will ask, sir, what is additivity? How to verify whether additivity additivity, whether the given system is following the principle of additivity or not. Is it clear? The word additivity simply gives an hint that the word is obtained from addition. जोड़, जैसे हिंदी में क्या कहते हैं, जोड़. एडिशन मतलब दो या दो से अधिक चीजों को आपस में जोड़ना. ठीक है, न्यूमेरिकल्स में 2 + 3 5, 5 + 3 8 ऐसे करते कि नहीं करते. तो here the same thing is there. Okay, what happens, suppose any device or system is there. I am drawing with a black box. ये क्या है, आपका एक सिस्टम है या और this is a system or a device is there in front of you. Okay, now I have to verify it whether it is a linear or not, and I know to verify it is a linear or not, I have to first check for additivity. Okay, so what I will do, I will apply an input, any input, let's say x1. This is my input. Definitely any system have two parts. You apply input and you will get certain. Do you agree or not? Do you agree or not? The system has input as well as output. Clear? Now, for example, your fan. Fan is also a system, a device. Is it clear? What is its input? Electrical supply. And what is its output? Rotation. And thus giving us air. Okay, this is the output. So any device on which you are working will have definitely input and it will give an output. Okay, so input and output are so. Now what I will do, I will apply an input x1. X1 can be anything according to device. जैसे हमारे पंखे के लिए x1 क्या होगा, voltage. What is voltage? I have applied a 220 volt and definitely I will get output y1. कुछ इनपुट लगाया तो मुझे कुछ आउटपुट मिलेगा कि नहीं मिलेगा. ठीक है, अब मैं एक और दूसरा इनपुट लगाता हूं of similar nature. Means suppose I have applied 220 volt and I have got an speed of rpm of suppose 500 rpm. How much? 500 rpm. Now I am applying 200 volt. How much? Definitely I will get another speed or same speed. Voltage is different, therefore the speed will be also different, and I got, and let's say output as y2. You understand this point? That applying x1 I got y1, or applying x2 I got y2. Now these are both same nature. Input does not mean पहली बार voltage लगा दिया, दूसरी बार मैं force लगा देता हूं. No, these are similar nature but of different magnitude or different, उनके परिमाण अलग होते हैं लेकिन क्वांटिटी सेम होती है. वोल्टेज एक बार लगाया 200 वोल्ट का, दूसरे बार लगाया सपोज 250 वोल्ट का, तो दोनों बार मेरे पास आरपीएम स्पीड, आरपीएम मींस स्पीड विल कम आउट डिफरेंट. अरे समझ में आया कि नहीं आया? अब मैं क्या करता हूं, सपोज आई अप्लाई एन इनपुट x1 plus x2. हाउ मच आई हैव अप्लाइड? x1 plus x2. ठीक है, इन दोनों का जोड़, एडिटिविटी, दैट इज वाई. ठीक है, एंड इफ आई एम गेटिंग एन आउटपुट इक्वल टू y1 plus y2, then I will say my system is obeying the principle of additivity. You got my point or not? You will all get this matter in the form of PDF. Concentrate on the explanation what I am giving you. Okay, I will provide all your PDF on your Google Classroom. Okay, but my main focus is that you should learn it, understand it, whatever I am explaining. So what is additivity principle? That for a given input x1 the output is y1, and for another input x2 the output is y2, and on applying an input equals to x1 plus x2 I am getting an output equal to y1 plus y2, means the system is obeying the principle of additivity. You got my point or not? कि सिस्टम एडिटिविटी प्रिंसिपल को ओबे कर रहा है. This is one thing is clear. But mind it, additivity does not guarantee you that system is linear. It may fail on the another law which is called homogeneity. If both are being followed, we say system is linear. So additivity is clear. To understand with the example, let's say a device is there. I have applied 5 volt. Let's explain whether I have applied 5 volt and I am getting 2 ampere. मैंने 5 वोल्ट लगाया और आउटपुट में कितना करंट मिला मुझे 2 एम्पियर. नाउ आई एम अप्लाइंग 10 वोल्ट and I am getting an ampere equal to 4 ampere. How much? 4 ampere. Now if I apply to the same system 5 plus means total equal to and if I am getting an output current equal to 6 ampere, that is 2 plus 4 ampere, then I will say my system is obeying the principle of additivity. You got my point or not? This example is clear. Now next, what is the next principle to be followed in supervision? Homogeneity. Now, homo word if Hindi means sum. Is it there? Sum. Is it clear? Now, how we interpret in mathematical form? Suppose the same system or device again, this is your input side and this is your output side. You got my point or not? Okay. Now I apply a input X and get an Y output Y. मैंने कुछ इनपुट लगाया और मुझे क्या मिला Y. Now I increase this input by certain constant value 2 times, 3 times, 4 times. Is it clear? जैसे 5 वोल्ट लगाया 2 एम्पियर मिला, अब मैं उसको कर देता हूं 4 टाइम्स, तो कितना हो गया इनपुट 20 वोल्ट. 5 into 4 कितना होता है 20 वोल्ट. मीन्स आई हैव इंक्रीज 4 टाइम. So if I have increased my output by k times, k is a constant. It can be 4, half, 3, 2, 1, 1/4, whatever, increase or decrement both. Not increment only, decrement also. Suppose I have reduced the input by 1 more 4 times. So here I have placed in generalized form what? Kx. What? K. And my output, oh sorry, Kx. And my output has also increased or decreased by k times. Then I will say my system is obeying the principle of homogeneity. You got my point? Example, suppose to this system I am applying a 5 volt and I am getting 2 ampere. Okay, and now I am applying 25 volts. So 25 means with respect to this input 5 times. K is how much? K is how much? 5. And if I am getting a current in the output side equal to how much? 10 ampere. Again here K is 5. Then I say my this system is obeying the principle of homogeneity. You got my point or not? This is clear. What is homogeneity and what is additivity? And the system which obeys both principle, which additivity and homogeneity, we say system is linear. And if any of the law fail, We say system is non-linear. So how do you define non-linear? System which does not obey the principle of superposition. This is clear or not? Okay. So from now onwards you have to be very cautious in defining the linear system. You will not repeat that your old school language, that if the graph is linear we will call it as a. I will give you an example through which I will prove that how the straight line of a graph make a system non-linear. That your assumption is that if anything you see in a straight line you call it as a linear. Do you agree or not? Previously this was the concept in your mind, that if any straight line is being seen you call it as a linear. Is it clear? I will give you an example. Now, what do you call this? Equation of a straight line. Okay, if you will draw on a Cartesian coordinate graph, if this is x and this is y, then probably it will be like this, I think so. Is it clear? No, I am not drawing according to slope, or it will look like this only. It is a straight line, everybody agrees? You got my point or not? But this is not a linear system. It is a linear straight line, but it is not a linear system. It is not an equation of a linear device. How? I can prove it. Just apply additivity principle. Just apply additivity principle. Suppose I have made a variable x1. I have made a variable x1 and I am for putting x1 I got output is equal to y1. Okay, let's say y1 is equal to 3x1 plus 4. This is the first equation. Do you agree or not? Okay. Now I am applying another variable x2. Therefore, what I will get, y2 is equal to now I apply y2 is equal to x2 plus 4. Another variable x2 and the output is y2. Now what the principle of additivity says? Now you apply input equal to x1 plus x2. So I am applying here an input equal to x1 plus x2. Okay, check my output y3 is equal to y1 plus y2 or not. Suppose I have applied another input x3 which is nothing but equal to x1 plus x2. Just place this value. What I will get? y3 is equal to 3 x1 plus x2 plus 4. Do you agree? Do you agree or not? Just open it. What you will get? 3x1 plus 3x2 plus 4. Now is this y3 is equal to y1 plus y2? Check. What is y1 plus y2? Add these two equations. What you will get? 3x1 plus 3x2 plus 8. But here it is coming what? 4. Do you agree or not? So this system is not, or in other non-linear. All we can say it is a non-linear. Have you understand or not? See? So, and in fact this is the very first necessary condition for the superposition law. Superposition principle. You have read superposition theorem? Have you read in first year? Have you read superposition theorem in first year? In your electrical subject? In that the very first condition was, necessary condition was, system should be linear. Then only you can apply superposition theorem. But the misconception in your mind, linear means having graph, straight line. Here I have proved that straight graph line does not means the system is linear. This is clear or not? So if likewise mathematically you can verify any system to be linear. Okay, for example, another example I give you, y is equal to x square. This is the equation from mathematics point of view. This is the equation of whom? Parabola. This is the equation of parabola. Okay, and the graph itself signifies that it is a non. We can verify it also. Should we verify? First of all, let's say y1 is equal to x1 square, equation 1. y2, I have applied an input x1 and getting output y1. What will be the? This is clear or not? ये समझ में आ रहा है? ठीक है, अब मैं क्या करूंगा? What is third step? I will apply input equal to x1 plus x2, and what will be the my y3? Open it, solve it, means further solve it. What you will get? x1 square plus twice x1 x2 plus x2 square. And what is y1 plus y2? What is y1 plus y2? x1 square plus, is y1 plus y2 is equal to y3? No, there is another term is there. They are unequal, that is y3 is not equal to y1 plus y2. Hence system fails in additivity. Now you need not have to check homogeneity. You need not have to check homogeneity. Is it clear? So you can simply say it is a nonlinear system because it fails in the additivity principle. So you directly say it is a nonlinear system. You got my point or not? How to check it? Clear? We can take another example. Y is equal to 3x. Now this used to be a straight line passing through origin as per mathematics coordinate geometry. Is it clear? So let us verify whether it is a linear system or not. So I will get y1 is equal to, for input x1 I will get output x1. This is the first equation. For input equal to x2 I will get an output y2. This is your second equation. This is clear? Okay, now I am applying an input equal to x1 plus x2. So I will get an output equal to y3, and this will be the 3 bracket x1 plus x2. When I further solve it, I will get 3x1 plus 3x2. Now I will add these two. What I will get? y1 plus y2 equal to nothing but 3x1 plus 3x2. Therefore y3 is equal to y1 plus y2. Hence there is a chances that it can be a system. Still I can't say because one rule is passed. Now I have to go to second rule. Okay, so what I will do, homogeneity, check for homogeneity. What is that? My equation was y is equal to 3x. Okay, suppose I increase it by k times. I increase the input by k times. So what I will get? Suppose I applied an input equal to kx1. Previously say input was x1. So it was how much? y1 is equal to 3x1. And now I increase my input x1 by k times. So my input is now what? Now I am applying an input equal to, यहाँ के input क्या लगाया? x1. And I am getting an output equal to y1. Now my input is, second input is how much? As per homogeneity principle, k x1. So let us see how much I am getting y2. y2 is equal to how much? 3 into k x1. Okay. Now just simplify it. It is nothing but k times y1. What is 3x1? What is 3x1? y1. So 3x1 I have substituted by y1, and therefore my output y2 is equal to k1. That is what the principle of homogeneity. Hence it is obeying the principle of homogeneity. Hence y is equal to 3x is representing an linear system. Are you got my point or not? This is clear. That how to identify mathematically whether the given system is linear or non-linear. Clear? Practically it is also easy. You have to first of all identify what is my input and what is my output, and according you must have an instrument to measure your input as well as output. So for example, if I take this fan, okay, I have already told you what are the input and output of this fan. Input is your voltage and output is your speed, that is in RPM. So what device you require to measure, which instrument you require to measure these two quantity? To measure the voltage you require voltmeter or a multimeter. When you go to the lab, everything will be exposed to you. What is the multimeter, what is the voltmeter, digital voltmeter, even digital ammeter, and also analog voltmeter, analog meter. Mind it, the technology has improved and advanced also. So nowadays we have some in the form of digital, but don't forget the conventional technology, that is analog system. And that is why in our department we have a complete, in every lab we have a complete small area is being there where the old devices are being kept. On the very first day you go through that old device, these are acting as the museum of the electrical engineering. Okay, you go through that was the technology in the olden days. Okay, so people were working still in your some instrument, some experiments you will be using that old technology instrument also, that is analog voltmeter and ammeter. Is it clear? So voltmeter is there for measuring voltage, and what to use the instrument to measure the speed. There is a device called tachometer. There is a device called tachometer. In our electrical machine lab we have a tachometer. Okay, you just connect that tachometer, it is on this shape only. On this there is a pointed structure is there that is being connected to the shaft of the fan. ये shaft है ना, गोल को दिख रहा है जो, ठीक है, इसके ऊपर लगा दिया जाता है, ठीक है, that will directly displays what is the speed of the fan in RPM. We have a both type of system, manually connected, and we have also an wireless. Means wireless is non-contact, not wireless, non-contact tachometer. Without touching the fan shaft I can find out the speed. That is on the laser based technology. I have to apply a strip over this initially when it is in not running condition, and then I can put my tachometer here, okay, and I can get, oh, what is the speed of that. I will explain you in the laboratory also. Is it clear? So without touching this, non-contact tachometer is also there. Nowadays we have a device in our laboratory that if I ask you measure the length, breadth and height of this room, क्या करेंगे आप? मैं अगर आपको एक एक्सरसाइज दूं कि इस डिवाइस, इस रूम का लेंथ, ब्रेथ और हाइट मेजर करें, कैसे करेंगे? सिंपल है. अरे टेप लेंगे कि नहीं लेंगे? मेजरिंग टेप. इज इट क्लियर? वो कपड़े वाली मत ले लेना जो टेलर यूज करता है, उसके लिए बाकायदा आपके स्टेनलेस स्टील की आती है, ठीक है. कपड़े वाली क्यों नहीं यूज करते? देखो हर किसी का अलग अलग प्रयोग है, ठीक है, क्योंकि ये कपड़े वाला तो कभी कभी आया आदमी, चेस्ट कितना है, हाइट कितना है, ये वो मेजर करेगा. दैट इज डेलिकेट और फॉर सॉफ्ट पीपल ओनली, बट हियर इट इज रफ मेजरमेंट फॉर सिविल पर्पज, for construction purpose. So always should be rough enough, and for rough enough we used to have a metallic tape. Okay, that is why using stainless steel, not the cloth made. Clear? तो आप क्या करेंगे? एक जना यहाँ खड़ा हो जाएगा, दूसरा जना वहां तक जाएगा, हाँ, फिर वो बोलेगा हाँ इतनी आई है. कई बार छोटी टेप ली तो आधा यहाँ मेजर करेगा, फिर उसको कहेगा इधर आ, फिर मेजर करेगा, फिर दोनों को ऐड के लेंथ इतनी है, ब्रेथ इतनी है. अब हाइट के लिए क्या करेगा? ही विल यूज दैट सच टाइप ऑफ लिफ्टिंग थिंग्स. He will move there and then he will just measure it, or by experience he will tell, it seems to be 15 feet, like this only. Okay, so these are all manual methods, but now we have a versatile device in our department also, in our laboratory. Okay, laser based distance meter. Laser distance meter, what is called laser distance meter? You just come to my chamber, I will show you, I have that. Okay, you just place on the reference, कहाँ से measure करना है, यहाँ से place it, just click it, the laser will point on it and then make a double click. Okay, it will give you what is the height, either in meter or in feet, in whatever choice. So you need not have to bring all this. Similarly, you want to measure the length. Okay, you just place it here, just click it, the laser mark will go there and it will indicate, yes, what is the length of this room. Similarly, breadth also. Is it not a versatile device? So now you need not have to depend on anybody. Is it clear? So I will show you when you will come to the laboratory that what is the laser distance meter. Similarly, we have a non-contact tachometer also to measure. So measure these two quantity, apply 50 volt, measure the speed, apply 100 volt, measure the speed. Is it clear? And now you can verify also. You have taken two readings. So first of all, additivity principle, how? 50 plus 100, 150 volt. Okay, you apply 150 volt, measure the speed. Now this, after application of 150 volt, the speed is equal to the speed of 50 and 100 volt or not? If it is there, it is obeying the principle of additivity. And now you have also reading of homogeneity, because previously you have taken on 50 volt and now second reading is on 100 volt, that is 2 times. Okay, so whether your speed has increased 2 times or not, if it is there, it is obeying the principle of homogeneity. But mind it, I have just given you 2 readings. So while doing the experiment is not justified by 2 or 3 readings. At least you should have a 10 readings. Okay, and there should be a conformity between all the readings. Errors percentage are there that can be tolerable up to 5%. That can be tolerable up to 5%. Okay, sometime 1%, 2%, but less than 5%. Then only you can say, yes, I have verified this law. Is it clear? Simply by taking one reading, getting the result, you just can't comment that I have verified the law. At least it should be 10 readings. And that is why in the labs you were being asked to take 5, 10, 20 readings to verify the given law. You got my point or not? Okay. So I have given you some example through which we have justified that whether the system is linear or non-linear. Next come your afterwards active, passive, linear, non-linear, and next come time variant and time invariant system. Time variant and time invariant system. Now these are also in pair. Now, what are these time variant and time invariant devices? Basically, the time variancy or time invariancy of any devices or any element is being decided by its parametric value. By its parametric value. Now, what are the parametric value? So let us say, so first of all I will give you definition. If the parametric value of any device or element changes with time, the device is called time variant system or element is called time variant system. And if the parametric value of the device or system remain unchanged with respect to time, it is called time invariant system. अगर समय के साथ अगर उसकी पैरामीट्रिक वैल्यू चेंज हो रही है, चेंजिंग विद टाइम, okay, then it is called time variant device. And if does not change, who does not change? Parametric value does not change, we call it a time invariant system. Now in the this now in this circuit theory which you will be reading in first semester as well as in second semester, if nothing is written, you will always assume system to be time invariant. In the sense, suppose in any circuit, this is a symbol of resistance, this is a symbol of resistor, whose a property what? Resistance. Now let's say it has a resistance of 5 ohm. Now theoretically you have read that the resistance changes with the temperature. ये आपने किताबों में पढ़ा है कि नहीं पढ़ा है कि जो रजिस्टर की जो प्रॉपर्टी होती है रेजिस्टेंस, ये टेम्परेचर के साथ चेंज होती है. इसका मतलब क्या हुआ कि यदि मेरा करंट कंटिन्यूस बह रहा है, मान लो मैंने एक रेजिस्टेंस में कंटिन्यूस करंट बह रहा है, 5 घंटे के लिए बह रहा है, टेम्परेचर राइज होगा कि नहीं होगा? हीट विल बी प्रोड्यूस, हीट विल इंक्रीज द टेम्परेचर and definitely temperature increase with resistance value will change. Is it clear? So practically you will say, sir, if 5 ohm resistance is given, it might have changed to 6 ohm, it might have changed to 7 ohm. Is it clear? But for theoretical consideration, we will always assume that once it is given 5 ohm resistance, it will remain 5 ohm for whenever you do numericals, for all time. Once it is being assigned 5 ohm resistance, you will not say, sir, I have done numerical, you have given numerical today, I have made the circuit and I have solved it tomorrow because circuit was on my papers, therefore current was continuously flowing, so resistance has changed from 5 to 6 ohm, so I will not do with 5 ohm, I will do with 6 ohm. No. ऐसा नहीं कि मैंने आपको एक न्यूमेरिकल दिया, आपने सर्किट बनाया और कल जाके आप करोगे तो सर्किट तो सर क्लोज था कागजों में, तो करंट तो बह रहा था, और करंट बह रहा था तो टेम्परेचर राइज हुआ होगा और वो 5 ओम से क्या बन गया होगा? 6 ओम. तो ये नहीं है. अगर एक बार न्यूमेरिकल में 5 ओम दिया गया है तो हम उसको क्या मानेंगे? 5 ओम. दैट इज वी विल कंसीडर इज अ टाइम इनवेरिएंट device or time invariant parameter. Is it clear? Once it has been assigned 5 ohm, it will remain 5 ohm. The same is true for the capacitor, the same is true for the inductor. Once I have assigned a capacitor, say 10 microfarad, I will always use a 10 microfarad. Is it clear? Similarly for the sorry, this is the inductor having property inductance and its value is 1 Henry. I will also assume it whenever I solve the numerical, I will always consider as a 1 Henry only. Is it clear? That is, it will be considered as a time invariant parameter. समय के साथ इसकी वैल्यू बदल नहीं रही है. So that type of devices are known as time invariant devices. You got my point or not? So in our circuit theory which you will be studying in this semester, next semester also, you will consider parameter to be time invariant. Time variant is clear, whose value, suppose this 5 ohm resistance was like this. Okay, the value of this resistance R is equal to 5T. Oh, sorry. Okay, suppose it was 5T. Clear? Means With time, the value of resistance is changing. After 1 second, it will may become 5. After 2 seconds, 10 ohm, like this. Is it clear? So at that, this type of elements will be considered as a time variant elements. You got my today's two terms: linear, non-linear, time variant. In the next class, we will deal with some of the terms which come while solving the networks or circuits, like node, junction, mesh, loop. Clear? Any problem so far? Any doubt?